Today our talk is on the Voyager system. So we'll learn from Dr. Javier Nicolau how to run jobs on Voyager. Dr. Javier Hernandez-Nicolau is a data scientist in our scientific applications group at SDSC. He has a PhD in plasma physics and nuclear fusion from the University of Carlos in Madrid, Spain. And he's been a project scientist at UC Irvine, and since joining SDSC in 2023, he's been working on the Voyager system and helping to develop codes in nuclear fusion, MHD and gyrokinetic fusion applications. And he's part of our user support group on the Voyager system, where he's working on a large number of AI models using the Intel Gaudi accelerator. So with that, I'll turn it over to you, Javier. You can start sharing screen when you're ready. And thank you, everybody, for attending.
Thank you, Mary, for the introduction. So, yeah, today we are going to talk about Voyager, and I'm going to show you how to run AI applications in this new architecture that Voyager has. So let me, yeah. So this is the outline of this webinar. So first, I'm gonna give an introduction of the Voyager system. Then that may be new for some of you if you are coming from more traditional HPC with something like a Slurm. This is a bit different. Voyager runs containers with Kubernetes, so this is going to be an introduction to this. The topic can be very complicated. Could be a one-week workshop, but here is going to be very simple, just an introduction for beginners. So if you have experience with containers, you can skip this section. I'm going to show you how to run a pod, which is an object in Kubernetes. So we will see how to run one of these objects on Voyager. Then the next section is going to be the main section of this webinar, which is porting a Pytorch application to our system. Then I'm going to show you that we can, if needed, you can parallelize your application and run it in Voyager using MPI. Then this can be useful for some users. They like Jupyter notebooks. We can do that on Voyager too. So I'm going to show you how to run Jupyter notebooks. And then finally, maybe you don't write your model from scratch. You may want to import it from Hugginface, or so you can do that as well in Voyager. So I'm going to show you how to do that. Okay. So what is Voyager? So well, it's an HPC system here at SDSC. And the idea of Voyager was to use a new architecture for AI to support researchers and engineers. And the main component of this HPC system is the Intel Gaudi accelerator. These are a bit different than, for example, GPUs and NVIDIA GPUs. These are designed specifically for AI applications, have been optimized. And that's the main, as I said, the main component of Voyager. As I said, Voyager is an HPC system and is funded by NSF. And this system is a category 2 system. That means that it has two phases. One is a test phase, and then is production. Right now, we are ending our test phase. It has been 3 years. And with that, this test phase, we have run a very large number of AI models from different fields. We have engaged with the research community, and we learn about what can be improved and what's better. So as I said, the test phase is ending now, and June 1st, our system is going to the allocation phase of production, and we will open our doors to host anyone. The architecture of Voyager, this is just a summary of what we have. We have, 42 training nodes. Each of these nodes has 8 Intel Gaudi cards with an all-to-all network communication between these processors. And on the right in this table, you can see that the memory of these accelerators is 32 gigabytes. And then we have a local storage, that's the scratch. And it's 6.4 terabytes. And this is a NVMe, so it's very fast. You can use this for Scratch. Then we have the compute nodes. That's for general purpose. We have 36, and you need to download the data, do some data processing. You can use them. Nothing special, just general purpose. Then we have the network is a 400 GB interconnect using RDMA over converged Ethernet. That's the network. And then our storage. So as I said, in the Gaudi nodes, the training nodes, this local NVMe with 6.4 terabytes. And then we have Ceph folder with in total is about 3 petabytes connected via the 25 GB. Here you can store your data, for example. You can access from the training node. And then you also have a home. We have a home file system, with 324 terabytes also connected to the computer, to the training nodes and compute nodes. So let's move to the software stack. This is an overview. And it's called Synapse AI. That's what Voyager is running. And on the right, you have a schematic of this software stack. But for the user, you don't need to know everything. I mean, it's at a very high level. You are running Pytorch, and you don't need to modify too much the code, just a very little modification. I'm going to show you later. So you can run Pytorch that is natively integrated to this Synapse AI, and you can run your AI application. But if you really want to change something from the kernel, something, build your own operators, you can do that. But that's for advanced users, and I think there are very few people doing that. So you can use Pytorch, and that's fine. This Synapse AI is it's updated periodically, and they include more features. They also work with, Intel Gaudi also works with the industry, so they are trying to update Pytorch and all this software stack. Okay. These are a list of examples. There are more projects and models running on Voyager, but this is just some of them, different fields like can be astrophysics, bioscience, chemistry. We have many AI architectures. Can be diffusion models, LLMs, VAE. So we have a variety of models and fields. Okay, so if you want to access Voyager, you have an AI project and you want to run it on Voyager, just please contact us. You can send an email to consult@sdsc.edu, and we can help you to get an account. Get an allocation. You can do that, for example, with the NAIR pilot program. I'm sharing here the link. You can, we can help you to request allocation time if you think it's complicated, but I think it's easy. And yeah, right now there are several projects that are already running using NAIR. So that's something you can do. Or now that in a couple of months, starting June 1st, Voyager will be in production. So you can request access via access like any other NSF system. So if you have an account with us, then you can access Voyager using SSH as almost any other HPC system. This is our login for Voyager. Yeah, you can use any SSH app for Windows or terminal for Linux or Mac. We have a repo with tutorials and models that can run on Voyager and have been tested. So I'm showing here this link, and I'm gonna show you exactly this repo. Here. That's the repo. We have a list of tutorials, examples, things you can use. It has been verified for Voyager by myself. And then there is a list of models that, they can also run on Voyager. So you can check them. If you have a similar application, and then you are good, there's no problem to run it on Voyager. So let's go back to that. Okay. All right. Okay. Let's talk about containers and Kubernetes. That's, as I said, is going to be just an introduction, something very simple for new users. Because it's different from, as I said, traditional HPC systems. So first, what is a container? So a container is a way to package applications. You put all necessary dependencies and configuration inside this container. And they can be very useful because you can install your own software. You don't need to contact the HPC administrator if you want to install any specific software. You can do it yourself. And it's also very portable. You can share with others. It's very easy. And that means that it's very easy to reproduce the same run with others. You have the container and you can share it, and that's it. Maybe you think this is like a virtual machine, and no, it's not. In a virtual machine, you are virtualizing the hardware. It's in a hardware level, so you have like an isolated machine. But with containers, the virtualization happens at OS level, so it's an installation of a process. So on the right, I show you here as this is a schematic of containers. So you have the hardware, your OS kernel, and then some container daemon like Kubernetes, something like that. Then you have your containers on top of that. They can run several applications or just one, for example, like this second container, and they have their own file system they can access, and they are independent. Okay, you have a container, so then what? So you can deploy them with Kubernetes. So Voyager uses Kubernetes as some kind of a scheduler. So you can And Kubernetes is an orchestration system, so you can manage containers using Kubernetes. And in Kubernetes, you have objects. Those objects describe the containerized applications, software, the resources like memory, CPUs, number of accelerators, all this. And to describe these Kubernetes objects, you can use a configuration file. Usually it's a YAML file. So in this file, you can define, for example, the smallest object in Kubernetes. That's a pod. That's a pod. Here for Voyager, you will have just one container, but you could include more containers in one pod. I think it's simple, just one. So you can put your application in the container and then the container inside the pod, and you can run this on Voyager. Its container needs an image. That image is includes all the necessary software to run your application. And on those images are, usually are externally hosted. For example, maybe you heard it about a famous repository, Docker Hub. This is for general, purpose. But if you want to run a container in Voyager, you need the image from Intel Gaudi because you need the software the Synapse AI to run Voyager. So I'm going to show you later one of these images and how this works. Okay. So you want to manage your containers application in Kubernetes. So you have the kubectl command. You can manage your objects. And so you can log in on Voyager and then load this module also to use a kubectl command. It's kind of simple. You want to create an object, you can do kubectl create and then file the YAML file defining your object. If you need to delete the object, just kubectl delete. You want to list all the pods that are maybe pending or running. You can do kubectl get pods, and I don't think you see this. Okay. If you want to see the logs from the pod, kubectl logs pod. So so this is a hello world pod. This is the YAML file. This is some very simple pod. So I'm gonna describe what we are doing here. So first you define the object with this kind pod, and then you put a name to the pod, like for example test. And then you write some specifications, what is inside the pod. The first thing, this is restart policy. Kubernetes is made for, to run services on the cloud, and you usually in those services you want to run always. So if something goes wrong, they restart the pod, and you don't want this here. So if your pod crashes for whatever reason, you don't want to restart again and again and again. Okay, then you define the container. You put some name. Doesn't matter. And then as I said, you need an image with all the software for your application. So you can use one from Intel Habana. This is the one we are using, for example, right now on Voyager. So the 115.1, this is the Synapse AI version. This is the one running right now on Voyager. Maybe in the future, probably in the future, we will update it to newer versions. So that could change in the future. But you can check in the tutorials. If we update it, we will update this example there. Then, so this application is gonna run like in Ubuntu 22. It's like, yeah, running from Ubuntu. And then, this is image is using a Pytorch, this version of Pytorch. Then in the container, you need to define the resources here, and requesting 32 gigs of memory, 12 CPUs, and 1 Intel Gaudi card. I mean, this is too much for this example, but this is for, it's some random application. Then the commands we want to execute like from terminal. So we should include this. And then the arguments, for example, we can do a hello world, and I'm going to show you how to do that. Let me go to the terminal. Okay. So I'm on Voyager. I'm going to go to the folder. So I'm going to show you how to run this. So I have a pod, the YAML file. Okay. This is exactly what I showed you in the slide. This is just a hello world pod. So close it. Okay, let's launch this pod. So kubectl create now file. Well, hello. Okay, so we have the pod. Let's check if it's running. So get pods. Let's see the list of pods. Okay, it's completed. It's very fast. It's a hello world, so it's done. So if you want to check the logs of the pod, just kubectl and then the name of the pod. So this test. Okay, it worked. Hello world. That's fine. All right. So this you should when this pod is done, when your application is done, you should delete the pod because it's not going to be here forever. This is not like Slurm or other HPC systems. In Kubernetes, you need to delete your object. So delete, and then name of the. Okay, and then should be gone. Yeah. Okay, so that's a simple example. Okay, let's go back to this. Let's skip this slide. That's what I show you in the terminal. Okay, yeah, that was very simple. So now let's move to something a bit more complex. So this is another YAML file, another pod. And here we are including something extra, and that's because maybe from your application needs to get access to a file system, to some folder. So you can define this here in the volumes. So you define these folders, and then the container can access to these folders. So here we define two. One is the name is a scratch. That's that local NVMe that I mentioned before. That's very fast. I think it can be very useful if you want to write from your application. But keep in mind that is purge. So when your pod is done, your data will be gone forever. So just be careful. I mean, it can be. I mean, it's very fast, but if you need to save the data, just move it somewhere else. Then in this example, I'm defining a different folder. That's somewhere I will work. I call it work here. Could be anything. And the path is in my home folder. That's the folder I'm using for this webinar. Okay, we have these two folders, and then we define the container again as before. Let's move to the next page. So yeah, we have the container, we have the image, and then we need to mount those volumes that I defined in the previous slide. So first I mount the scratch as the /scratch, and then that working directory as a /work there. So here we define the name of the folders that container will see. Then the resources, and then we execute some commands. Here the first one is HLSMI. That's very, I mean, that's optional, but that can be useful. It gives you some information of the Gaudi card. Yeah, but that has a this option. So yeah, we execute this, then we get into the working directory. We could do, yeah, pip install or whatever package. If you need anything, yeah, you can install here. And then, yeah, you can execute your application. I'm going to show you later how to run this because the YAML file is the one I'm going to use for an example I'm going to show you later. So, okay, let's move to the next section, which is the main section. This is maybe what you are interested in. That's we are gonna take a Pytorch application that is has been running on a GPU, an NVIDIA GPU, and we are gonna port it to Intel Gaudi architecture, so we can run it on Voyager. It's relatively simple to do that. We don't need too many steps. So the first thing you need to do is to, in your Python code, is to import the Intel Gaudi Pytorch framework using this command. Then you need to change the device. So if you were running with GPU, you probably have something like a CUDA here. So you need to change it to HPU. And the next step that needs to be done when you are training or when you are calculating the loss. And you need to include this mark step every time you do the plot work pass. You are doing the optimizer step. And then you need to do it as well if you are doing loss calculation when you are testing or validating your model. I'm going to show you an example how to do this. So this is going to be a convolutional neural network. It doesn't matter too much the model, but it's going to be like a ResNet model with a NIST data set. So let me go back to the terminal. So I'm gonna, we have one file for this application is run one cap. Go to the bottom. So it doesn't matter the model. It's just I have here a generic example for this is a textbook example of a CNN in Pytorch. So first thing you need to do, import the Intel Gaudi, sorry, the Intel Gaudi Pytorch framework. So we can do this here. Then in this example we have arguments. Here defining the model, let's skip this. It's okay, it doesn't matter. You have the model, this is gonna be a ResNet. Here is the train function. I'm gonna go to this function later. We have the test function. And let me go to the main part of the code. I'm going over all of this. It's going to be fast. As I said, this is a simple example here in Pytorch. So you have NIST data set. Then you can make it smaller. This is optional. You can create the data loaders from training and testing. This is something for the model. And then here, that's important. When you, usually when you create the model, you move it to the accelerator. So before in GPUs, you can use the CUDA, but now here in Voyager, you will use the Intel Gaudi card. So that's, you should change that to HPU. So okay, we move the model to the device, define log, define optimizer. Okay, and this is the main loop in this model. So first we train the model in this first step. Let's go with the train function. Yeah, it's here. Put it in train mode, this model, then yeah, this is the loop for the train loader. Move data to the device, the forward path. You need to, yeah, as always, set range 0 for the optimizer, do the backward pass. And here, that's where you need to include this mark step. That's important after the backward pass. You need to do this. And then when you are updating the model with a step, you need to as well include this mark step here. Okay, that's it for training. And I'm gonna move back to the main. Okay, so we were training inside the main loop. Then we with some calculations, that doesn't matter. And here we want to yeah, do a test. We want to validate our model. So we call this test function. And then we go back to the test function. So we have the test function. Yeah, so model in evaluation mode. And again, we have this loop, move things to accelerator. Here we are doing the forward pass. We want to make a prediction, calculate the loss. And we need to add, after calculating the loss, we need to add, again, the mark step. That's important. You need to do this. And okay, after that, yeah, so there are some calculations for the to check our model, and then we are back to the main part of this model. And then that's it. Basically, that's it. Then we have some printing, and then we nearly stop. But that's you don't need that for your application. So let's try to run this. Because right now, I mean, we have our application ready for Voyager. So we have another part for these minutes, which is that's the YAML file I showed you before in the slides. So we are gonna run this. Jupyter create. Okay. Okay. Yeah. Oh, yeah. I'm gonna open again the YAML file. Yeah. As I said, this is what I showed you before. So we have now our new folders that now the container can access to, because this is my home folder where I have this application. So then I can call it with CD. I mean, I can access to this folder and execute the application. Let's see how it's going. So now probably still running. Okay. So now let's take a look with the log. Let's see what is it. Okay, now. Oops. Typo. Oops, it did that. Okay. So remember, I was using as the first command HLSMI. That's this box here that gives you information about the Gaudi card you are running. As I said, it's optional, but I mean, I always using it, so I'm sure that everything is fine. So the first line is the image you are using. This is the Synapse AI version from the image. And the second line is the driver installing the, the hardware in the Gaudi card. Then you have some information like memory, processes running. Because I executed this at the very beginning of this container, there was nothing running, so there is nothing. But if something is running, you will see here that process. And then when you start to move something to the Gaudi card or do something with the Gaudi card for the very first time, you will see some configuration parameters. That's okay. You don't need to worry about this right now. There's some info. Let's see if it's still running. Yeah, okay. It's still running. Should be ready in a few seconds. Sometimes it takes more time to print from the model. Because this should be fast. It's a small data set. It's more than I tested before. Let's wait a few more seconds. If not, I will move to the next thing. But I think okay. Yeah, because I'm printing every epoch, and yeah, sometimes it's in the cache and takes a few seconds to show in the logs. Let's see if yeah, it's done. Okay, let's see. That's okay. Okay, it's done. Yeah, here we can see the output from this model. And yeah, it worked and as we expected. Okay, good. So let's go back to the slides. Yeah. Okay. So I'll show you a very simple Pytorch application, but maybe you have something a bit more complicated. Yeah, maybe you have CUDA API calls. It's okay. Intel Gaudi can use something called GPU migration toolkit, and what this tool is doing is just porting for you your CUDA calls to their own from the Intel Gaudi card. I can show you in their documentation here. So this is the Intel Gaudi documentation is very useful. And yeah, if you have a bit more complicated model, you can use this migration toolkit. And you don't need to do anything else, just you need to include this command when you are executing your model, and the Synapse AI is doing it for you. But if you have complicated models, you can always contact us. that's fine. Yeah. For example, maybe you are using deep speed. It's okay. You can use the 4th version from Intel Gaudi. It's fine. Maybe you are your code is parallelized, and you are using, for example, DDP for distributed training, and you are using NCCL and NVIDIA backend. It's okay. You can use the equivalent in Intel Gaudi, that's HCCL. And yeah, as I said, feel free to open a ticket or just contact us. We can help you with your AI application. And we have every 2 weeks, we have a meeting with Intel Gaudi, Intel Habana, and their experts can help us as well, or can help you to run your AI application. They are very helpful, and yeah, they have been helping us in the past, and it's fine. There is always a way to run your model. It's okay. All right. Let's talk a bit about parallelization. I didn't want to, because we are restricted to 1 hour. I don't have too much time, so I just have one slide for this. But yeah, you can run a parallel job in Voyager. You can use MPI. So yeah, as I said, you can scale your application to multiple cards or even nodes. It's relatively simple. If you have less than 8 cards, you have this bot object in Kubernetes. You can still use that. You can use the MPI run command, and that's it. We have some tutorials again in our repo. Please, if you're interested, take a look. And as I said, that was for 8 cards. If you want to run in multiple nodes, you can also do that in Voyager. So you can run in 16 cards or more. But now, if you want to do this, you need an inference object. This is called MPI job. And again, I have examples on this repo, so you can take one of these examples and use it. I don't want to spend more time in this, but this is a bit more advanced. But if you are interested in, yes, please contact us. Okay, so now let's move to notebooks. I know some people like to use notebooks. I mean, I do sometimes. So I'm going to show you how to run them on Voyager. So these are the steps to do that. But I want to do it in for you right now. Yeah, so first we are going to launch a pod. And this pod is going to install Jupyter, and then run it. So let's do that. So, sorry, fill this here. Let me make this. Okay, it's just to. I don't want to keep it here forever. That was the previous example. Okay, so CTL create spot Jupyter. Okay, let's open this YAML file. Let's okay. The simple pod. Now here, we have some folders we want to use in this Jupyter notebook. Scratch. This is this working directory in my home folder. Daemon also using another folder for this is the next example we are going to see for a Hugginface example. So I'm doing it right now. So I'm using a folder from Ceph. We can load it to here, can define it as a volume, and then we can mount these volumes here. Yeah, so this pod is simple. We want to, yeah, as I said, install Jupyter and then run it. So I did it. Yeah, so I already created this pod. So let's take a look. kubectl get pods. It should be running. And kubectl logs. Let's see. All right, now it should be fine. So with pip install, so the Jupyter has been installed in this pod. Then is we are running Jupyter, and we have some links that we will use later to get to, to access to his notebook, his Jupyter notebook. Let's go to the slide. Next step. Yeah, just check the links. And we need to port forward the pod so we can access to it. So I'm going to copy and paste this. Copy. So we need to do kubectl port forward pod name. And the name of the pod is, you can define the name as, in my case, is this one here. Let's copy this. Okay, that's the name of the pod. And then here, those numbers, the 9888, it doesn't matter, this port, it could be any number. I'm using 9888, but if someone is using it, you can use a different one. It's okay. So let's, okay, execute this. Now it's working. So let's see the next example. We need to create an SSH tunnel from the client, which is usually your PC, your laptop. So you should do this SSH tunnel. So let's go to my terminal. This window is Voyager, but now this is my my laptop. So I already did it before, but let's do it again. So this is, as I said, the SSH tunnel. Remember, this 9888 could be any number you have defined before. So, but in my case, this is the one I'm using. Okay, now it should work. So, last step is copy that those links you saw before to your browser. So let's go back to Voyager, and you have here, for example, this link. Let's go to, I'm going to my browser, copy it here, and that's it. This is my browser in my laptop, but this Jupyter notebook is running on Voyager. And this is the root folder in the container. I have this work there folder. I have my examples here. And we can, let's open the notebook. Okay. I'll just do a quick check. HLS, MI. All right, cool. That's the info from the Gaudi card. Everything looks fine. So yeah, good. Usually when you are done, when your Jupyter notebook, you should close the notebook, but you should delete the pod. If not, it's gonna be running forever. Don't forget about this, because if you will be charged for that. So keep in mind, it's not just closing the tab in your browser, but deleting the pod. I'm not gonna do that because I want to run an example on Jupyter. So I'm gonna move to the next thing. Yeah, and that's Hugginface models. Because maybe, yeah, you don't, I mean, you didn't write your own model from scratch. You want to use a diffusion model, or I don't know, fine-tune a LLM using a pre-existing model from Hugginface. So you can do that on Voyager, and it's quite simple. And but if you want to do that, you're gonna need Optimum-Habana. That's that package. That's the software that people from Intel Gaudi has been developing for, I mean, on top of the Hugginface transformers and diffusers. And the idea is that you can use the Hugginface transformers or diffusers and in the Intel Gaudi accelerator. It's simple, and for example, here is a list of so yeah, that's the list of the models users are running right now on Voyager. For example, LLMs, they're fine-tuning Llama, Gemma 2, yeah, DeepSeek. Some people are using the TGI for LLMs, diffusers like a Stable Diffusion 1.5 or Excel or open model like Common Canvas. And there are users also running large multimodal models like Qwen2, Llama 3.2, or Lava. That's also possible on Voyager using Optimum-Habana. And here I'm showing you on the left, that's a colleague shared with me this plot is to show you the performance of those models, Optimum-Habana in our Gaudi cards. So the horizontal axis, that's the number of HPU devices. That's the number of Intel Gaudi cards. The left vertical axis, that's the time to run. And here we are fine-tuning Llama 3 with the alpaca data. And on blue, that's the efficiency running on different, I mean, multiple cards. It's very good yeah, efficiency until 8 cards. Efficiency drops, maybe because the data set is so small, and maybe, yeah, we are using too many cards for a small data set. But for a small number of cards, that's fine, and that's running in multiple cards is good. I mean, you can do that. So I'm gonna run an example for you. I'm gonna show you how easy it is to do that. So I'm gonna go back to the Jupyter notebook. I'm gonna run one of my notebooks. We're gonna show you later a GitHub repo with those files if you want to use them, but you can also check our Voyager repo with examples. They are the same. So let me open this notebook with this example. Okay. So this is, okay. So what I'm showing here right now is an example of diffusion model running on Voyager using Hugginface diffusers using Optimum-Habana. So in this case, I'm using Stable Diffusion 1.5. You could use any other model from Hugginface. This is something I already have here. Okay. So first thing, check the Gaudi card. That's, as I said, it's optional, but just to verify that everything is fine. Then we need that package, the Optimum-Habana. So we need to do a pip install in this notebook. This is the version we have been working for the current Synapse AI version in Voyager, which is 1.15. You may use a different version, but I'm not sure if that's going to be compatible or you're going to have issues. So I'm sure that this is working. And yeah, that works in this example. In the future, we are going to update Voyager to later version of Synapse AI. So maybe this is going to change in the future. But if you have any question or again, contact us, please contact us. We will help you. So, okay. So we install Optimum-Habana. Yeah, we did that. Yeah. This Optimum-Habana is also installing transformers, diffusers from Hugginface. Okay, good. Okay, you need to load the package for the diffusion. In this simple example, just we need two things: the scheduler and the pipeline. And we need to use the one from Optimum-Habana. So we use these two classes. They have this Gaudi at the beginning. I'm going to show with you later, but there is a repo from Optimum-Habana where you have lots of examples. I think there is good documentation of what you can do. So I'm going to show you the link later in I think in the next slide. But yeah, here you can see lots of examples of transformers that can be used in Intel Gaudi cards. Same with the diffusers. Okay, let's go back to the notebook. All right, we import those classes from Optimum-Habana. So one links, that's fine. And then we need to load the model. That's as I said, that's the stable diffusion. You could download it directly from Hugginface, but I didn't want to do that during this workshop, this webinar. And so I downloaded it before and I store it in my Ceph folder that then I connected to the container using this slice dataset folder. So you can do that. So you don't need to download every time the model. Okay, so we are loading the model. And then we need to create the scheduler with this model. That's fine. Then we need to create a pipeline. This is a very high level class from Hugginface. Because this is a very simple example. And we create this pipeline where we create, this pipeline using this model with this scheduler, and then we have extra parameters from Intel Gaudi. You can see the examples, but and this is something you can use for the fusion. Okay, so I created this pipeline, was find some information. And then, we can run inference using the pipeline class. So I'm running it here. This is my prompt. We're in San Diego. We have pandas and tacos. So let's see a panda eating a taco. There are some extra arguments like the number of images or the batch size, but you can play with those numbers to make it more efficient. That's what I'm using here. Okay, this is one of the images that I just created for you. So this is a panda eating a taco. There is another one. Okay, so it worked. Great. Yeah, nice typos. Okay, lunchtime here. All right. So that was the example running diffusion with Hugginface model on Voyager. If you want to run LLM, you can do that. We don't have time here for all of this, but there are many examples in that repo. But you can always contact us. Let's go back to the slides. Yes. Right. Yeah. Some useful links because we're ending our webinar. So this can be useful if you are starting with Voyager and Intel Gaudi architecture. So first, yeah, the link to the documentation, the official documentation from Intel Gaudi. Another link for Pytorch in Intel Gaudi. They have examples, tutorials, can be, yeah, very useful. Then we have two repos. The first one, that's the official from Intel. We are not a part of this repository, but they are providing models that they tested on Intel Gaudi. They are maintaining those models, so you can check them. And then we have our own repo from, on Voyager, where we have tutorials and the YAML files or instructions to run the models from the official model from Intel Gaudi. And then the last link is what I showed you before about Optimum-Habana. If you want to use Hugginface models, go to this repo and you can learn more about this. So yeah, this is a summary. This is the summary of this webinar. So we have seen that Voyager HPC system, there is the Intel Gaudi accelerator. That's the main component, and it's specifically designed for AI. So you can run AI applications in Voyager. Those applications will run on containers and are managed by Kubernetes, and you will need to use the kubectl command to manage those objects and containers in Voyager. We have seen how to port Pytorch application. It has been relatively simple. I think it's kind of simple to do. And then I'll show you how to run a Jupyter notebook. If you like to use notebooks, you can do that on Voyager. And we have seen how to use Hugginface models on Voyager using Optimum-Habana. Yeah, that's it. That's all I wanted to say. Thank you.